So time to have a look at the graphs that represent uniformly accelerated straight line motion. We have four possibilities here regarding signs or directions of initial velocity and acceleration. One possibility is when both are positive, that is, both are in the same positive x direction. The other possibility is when both are negative, that is, both are in the negative x direction. And then we have a possibility where u is positive in positive x direction, whereas a is opposite, and then in the end u is negative and a is positive. The first two cases where initial velocity and acceleration are in the same direction are cases of speeding up motion, that is where speed increases, and the lower two cases are where the speed is decreasing. So we are calling these cases as speeding down motions. We are calling these as cases where it's a speeding up kind of motion. Now, why exactly this happens, we'll be able to observe better once we have had some good look at the graphs. Now, to start with, we are having a look at the A versus T graphs. So the first kind of graphs we are studying are the AT graphs. Now with purely AT graphs, we have only two possibilities, where the acceleration may be positive, as in this case and this case, or acceleration may be negative, as in these two cases, 2 and 3. So for positive A, we will have something like this. This is the A versus T graph, and if A is positive, the graph will be above the time axis. So the graph will be here, and since acceleration is constant, we have a horizontal line, so that for any value of time, the magnitude of acceleration is the same. That's the case for a positive acceleration is positive, and the other possibility is where A is negative, and when A is negative, acceleration will be plotted below the time axis, so it will be like this. Here the acceleration is negative, so that's the graph. You will recall that the area under the acceleration time graph in any given interval gives you the change in velocity during that interval, and later on when we take up problem solving, we'll be making use of that interpretation. So these are the two possibilities for the AT acceleration versus time graphs. For velocity time graphs, well, we have four different VT graphs corresponding to these four different cases, and we'll take them up one by one. So for case 1, we are drawing the VT graph. So V on the y-axis, and we have V on the y-axis and T on the horizontal or the x-axis. Now the graph starts with a positive u, because u is given to be positive and the acceleration is positive. Now recall that acceleration is the slope of the VT graph, and here we are dealing with uniformly accelerated straight line motion, so acceleration is positive as well as constant. So we have to have a graph with a positive constant slope, and that's very easily drawn. It is a graph with a positive constant slope. Now recall the interpretations for the VT graph. The slope at any point gives us the acceleration, and the area under the VT graph gives us the displacement, right? So That's the VT graph for the first case. For the second case, our VT graph looks like this. This is the time axis, v-axis. Now initial velocity is negative, so the graph actually starts below the time axis, minus u. It was plus over here. Also the acceleration is negative, so it's a downward sloping straight line. Acceleration is negative and constant, so you have a straight line because acceleration or the slope is constant, and it's downward sloping because it's a negative slope or negative acceleration. The third possibility, where u is positive and a is negative, now the third case, u is positive while a is negative. U here is positive plus u, and acceleration is negative. So it's got to be a downward sloping straight line. Now this kind of a case is actually pretty interesting. At this point of time here, what has happened is the direction of velocity has reversed. Prior to this time, velocity was positive, and after this time the velocity is negative. So what was happening was, till this time particle was traveling in positive x direction. Over here it stops momentarily at this point of time and then reverses direction and starts moving in negative x direction because now the velocity is negative. So the particle has taken a U-turn over here, and therefore we choose to call this the turning point. Now two very interesting things actually happen at the turning point. Before the turning point, velocity was in positive x. After the turning point, velocity is in negative x. So the motion direction has reversed here. Also, another interesting thing that has happened is that before the turning point, velocity was positive while the acceleration for this motion is throughout negative. So velocity and acceleration had opposite signs. Now this positive velocity is decreasing in magnitude and attaining a zero value over here. So velocity, which was initially plus u, has now become 0. Now speed is magnitude of this. So initially speed was u, and now the speed is 0. So from u to 0, speed has actually undergone a decrease. And then what happens is you have a negative velocity, which means it's in the negative direction of x-axis. But you will notice the negative magnitude of velocity starts to increase now after this time. So before turning point, the motion is a speeding down motion. But after turning point, velocity and acceleration are in the same direction. You now have negative velocity and negative acceleration, which says the speed is now increasing. So remember this very important little point, that before a turning point appears, speed will be decreasing, and after the turning point, speed will be increasing. Now this motion where initial velocity and acceleration have opposite signs will always involve a turning point. At the turning point, two things happen. Motion direction reverses and the nature of motion changes from speeding down to speeding up. The same kind of turning point will appear in the fourth case as well. So where you have opposite directions or opposite signs of initial velocity and acceleration, the motion will involve a turning point. So let's have a look at the fourth case as well. This is V, this then is T. initial velocity is now negative. So we are starting at minus u, and the acceleration is positive. So we have a graph with a positive constant slope. It's a rising graph. This here is the turning point. Before the turning point, speed decreases. Now initially the speed is u, and then it decreases to 0, and after that speed starts to increase. So before turning point, it's speeding down, speed decreases. After turning point, speed starts to increase. So these are the 4 possibilities for the VT graphs. We will now look for the next useful kind of graph, and those are the XT or position time graphs. We've already gone through the VT graphs here, and the next set of graphs we're looking at are the position versus time graphs. Now these are the important or the more useful kind of graphs. You can always draw graphs between acceleration versus position, velocity versus position, and so on and so forth, all kinds of possibilities. But they're not necessarily greatly useful for problem solving. They're graphs drawn to ask you questions about those graphs, but they're not really useful in practical kind of problem solving. So these are the important ones, and we'll later on, if we feel like, we'll have a look at those other kinds of graphs as well. But as of now, we are looking at these 3 kinds: AT, VT, XT graphs. Now what we have done is we have drawn 4 kinds of VT graphs. We will now be drawing the corresponding XT graphs for these 4 cases. So the first case here is this one. X versus t, and we are starting at x naught in all of these. Now you will recall that the slope of xt graph is velocity. Now here velocity has an increasing magnitude. It's a speeding up case. When speed is increasing, slope of the xt graph is increasing, and the slope here is, the velocity here is positive throughout. So we have a graph with positive slope which is increasing because speed is increasing. So the graph for this particular motion, the xt graph for this motion, will be a graph with positive increasing slope. Remember, v velocity is the slope of the xt graph. Over here velocity is positive, so we have a positive slope for the graph all throughout. Also velocity is increasing in magnitude, so slope is increasing in magnitude, and therefore you get a graph like this with increasing slope. Now the xt graph will actually be a graph of something like this: x is equal to x naught plus ut plus half a t square. Now graphs which involve the second degree, power t to the power 2, such kind of graphs are actually called parabolas. This particular curve is a parabola, and for all these 4 cases we'll have parabolas as our graphs. Let's have a look at the second case, just to keep a recall value for you. Parabola. The second case, where both are negative, now we are starting at, say, x naught. Now velocity is negative always, so the slope is all the time negative. We'll have a negative slope. Also, magnitude of the velocity, that is speed, is increasing. So we have a graph with negative increasing slope. That means we have a graph which becomes more and more vertical as time proceeds, and we have a graph that looks like this. Again, this is a parabola. The third case now, which kind of is more interesting. Now, we are starting at x0. Initially, we have a positive velocity. So we have a positive slope initially, but the slope decreases to 0 at the turning point. So positive slope for some time, and at the turning point, at this time, let's say t0, the slope decreases to 0. The velocity has decreased to 0. So at t0, the slope is 0. The graph is horizontal. After that, velocity is negative, so we have a negative slope from this point onwards. Also, the speed is increasing, so the slope is increasing. So we have a positive decreasing slope, positive decreasing slope, speed decreases to 0, speed decreases to 0, and then negative velocity, so negative slope, which is again increasing because after the turning point speed increases, so magnitude of slope increases as well. The fourth and the last case is corresponding to this this graph here. Once again, we're starting with say some x0 here. Initially the velocity is negative, so we have to have a graph with negative slope. That negative slope decreases to 0, that is because speed is decreasing to 0. So we have a graph with initially decreasing negative slope. Decreasing negative slope. Slope becomes 0 at the turning point. Velocity becomes 0 at turning point, slope becomes 0 at turning point. After that we have positive increasing velocity, so we have positive increasing slope. And that's the entire set of 4 different kinds of graphs that we can draw for uniformly accelerated motion. Very, very important and very useful ideas here. Please make sure you watch this video a good number of times so that everything discussed here stays on your fingertips. Extremely useful, extremely important graphs here. Thank you very much.